We are live and recorded, not live. Welcome to Physical Science in the AM. We're taking a look at a lesson in progress. I'll backtrack a little bit. Total internal reflection. We did a demonstration or two, but we're talking about between a slow and a fast medium. There's a point, it's called the critical angle, where all light cannot pass through. It'll totally be reflected, non-refracted. Pause the video, examine that diagram if you wish. But the critical angle is when light is refracted to an angle of 90 degrees, and we're just solving a problem. We're calculating the critical angle of crown glass and air. We're using Snell's law, right? So we're going to sub in for the refracted angle 90 degrees here. We're going to look up crown glass and air. Well, we're going to use 1.00 for crown glass. I look it up here. Oh, 1.52. So I'm going to go back there. Pretend I need to write it down. I already have it written down. 1.52 for the crown glass. Right? That's what we just looked up. We're trying to find critical angle. One we're using for air. We don't need the extra decimals. It can't be one. Doesn't make the sine of 9. And if you don't know the sine of 9, you've got to calculate. It happens to be 1 as well, so it makes the calculation really easy. Trust me, it is. It is. Sine of 90 degrees is the 1. So we sub these things in here, and we solve for that. Now, when I did this before, I didn't sub in the 1 for the sine of 90, but that's what it is. It's really 1 times 1 on the top. Divide by 1.52, so it's quite an easy calculation that way, and we get a decimal for this. So what I was saying. And we want to find the angle inside the sine function, so we're going to use that -1 button. Get the decimal for it. I forget what it is, so I'm going to just 1 divided by 1.52. I do it all in 1 second. That, what I'm really plugging in is sine inverse function. Take a couple of decimals in there. 6, 5, 7. I'll keep this 9 as extra. Because I really wouldn't round off. I would just do it all in. You can get the decimal first and put it into your calculator, and then you get an angle in degrees. 41 degrees. So it's the same mathematical formulas as before, except that you're using 90 as the refracted angle. That's all it is. So math-wise, it's not a lot. Any questions at this point? I hope not. Now, I don't know how many of you got a chance to really work on those problems, because some people were catching up. I was telling you I'm going to give you time, but I'm going to just tell you what's attached there. When you get time to read through it, and when you get time, do get time. So there's a little right up here about total internal reflection, another diagram showing it. And diamonds are sparkly because of the high index of refraction. Look on the list, I think it's 2.42. The higher the index of refraction, the slower the speed of light in that material. The diamonds are super sparkly because of this. The light bounces around several times, and they're cut just right with these angles to make them look extra sparkly. Anyways, I say get a chance to do this. I was talking about fiber optic cable. How you don't lose the signal because it just total internal reflection bounces around it. Now, if you want to jot down and try some of these practice problems, jot down ABC's answers, 48.8, 24.4, 33.3. And there's that same chart again, too. right beside these problems. Same chart as before. I'll give you a second to do that. And then we have, a second here. Okay, let's, that one's done. Okay, this is it for new material. Like I said, it's the same formula, so the math isn't different. You're just putting 90 in for the sine R, sine of 90, and that's just one. Okay. So yesterday's problem set, the fraction calculation problems. Here are the answers for the 4 and then the set of 3. I'm going to just move these here. You guys are young adults. You know how much practice you need. Some of you can just jump right into the set of marked problems if you need. Some of you need this practice. Here it is. So I'm going to pause the video or stop the video. See that from the other day.